Alright. This is question 1. So for D, you have to put the 27.0 kilometers first into the equation. So I can go ahead and work this out here. This will be D1 for what I'm doing here. And this would be your angle, which would be, let's start with this one first. So it'd be negative 35 degrees. And to do this, if you open your calculator,
Everyone.
and this is for the X1, D1.
Okay, so what do we need to make sure our settings in that we learned yesterday?
Make sure your mode is in degree on your calculator. Is everyone's calculator in degree? Yes? Okay.
Yes.
All right. So what you want to plug in the calculator, if you put in 27.0, make sure it's in brackets. Press the cos sign, another bracket for negative 35 degrees. That should equal, well, what you should get is 22.1171052. But if you use the sig fig rule, you will get 22 kilometers. And that will be your answer for the first angle up here. Let everyone get that there.
And is there a way that we can document it on our diagram?
Up here.
Yeah.
All right, so that first one will be 22, and now we got to do the next one. So, where you going? How's that there? Okay, for D2, you will put down 41.0 kilometers. And for your angle, you'll use the angle 2, which is 65. And instead of using cos for this one, use sin. So if you go in your calculator, you put in the same thing except you use sin, and your sin will be negative 35. So 27.0 bracket sin, and then, excuse me, it was 65, not 35. So you have 65. Okay, and you should get 24.47031025, and it should run onto 25, and that will be your answer for that. Okay. And there you go.
Anything else you want to add?
Make sure you keep your calculator in degrees.
Okay. Anybody have any questions for Jordan? Thank you, sir.
Thank you.
So he did it very simplified, and I liked how he did it very simplified and how he used D1 and the angle, D2 and the angle. But what is all of this?
essence, 2 days, you have to combine them to get your total.
That's your total displacement.
Okay. So they did day 1, X and Y,
Yes, ma'am.
day 2, X and Y,
Then you combine them.
then you combined your totals, and then you're ready to solve down here, correct? And you're using those numbers. Is it necessary to do all those steps to get the correct answer?
You should be able to. Wait, yeah.
Yeah, right? Okay? So it's not as complicated, but there is a lot of steps. Why is there so many steps here compared to what we've done before?
We were just doing one set of data, and here we're doing 2.
Perfect.
This is more precise.
It is more precise. Now, would you like me to give you the answer for the problems? And if we have a problem, we can work it together. How would you like to do this?
You
Okay? So, for question 1, what did you get? What was your answer for question number 1?
I thought we were just supposed to read.
Yes. Oh,
Yes, ma'am.
Yeah, I did too.
Yes, ma'am.
oh, on page 93?
Yes, ma'am.
Oh, okay. All right. So can we take a moment? And I'll give you a moment, and I would like you to do the practice problem number 1.
Yes, ma'am.
You're going to do it,
Which page?
excuse me,
Practice problem number 1 on which page?
on the next page. It's on the back of that page, right? Let me make sure it's there. Yes, sir. So you're just doing, you can only, you just do the first one. Don't do any other ones. Okay? Now, while you do it, at your desk, Miss Sloan is going to do it on the board. Okay? You're going to try your best to concentrate on what you're doing, and I'm going to concentrate on what I'm doing, and let's see if we get the same answer.
I have a question. If it says that it's going down, would that be negative?
Well, think of
Directed
coordinate
down the
systems.
field.
Think of coordinate systems, north, south, east, and west. Now, what I want you to do is I want you to try on your own first. And if you get to a stumbling block, you may look at the board, but do not copy the board because that's not going to help you. And we'll talk about it.
Yes, ma'am.
Fantastic.
It makes sense. It's just a lot of writing.
Well, the problem is you gotta do your X and your Y, and you have two places that you gotta do. So you have to get those numbers before you do the totals, before you do the square root. That's why I was saying a few minutes ago, we only need to do two of these because they're so long.
If they would just give us our X total and our Y total would be.
Right. But what they're trying to see is, this is just repetition after repetition, but they want to make sure, if I give you this, can you get that? Because you're right. They could just give you the totals and you'd be done, but they want you to practice here at the very beginning to make sure you know how to get the totals, and then from now on, they'll give you the totals. If you would like, try Bailey to do number 2, because that's the next one we're going to do.
Okay.
Anybody need help? Because this is simple, it's just a lot of work. So if you don't mind, can I start, or do I need to wait a few more minutes for you? Okay, so the first thing you're going to do is you have to look at what the question asks. So it says a football player runs directly downfield at 35 meters, for 35 meters. So my distance 1 or displacement 1 is 35 meters. And it says, before turning to the right at an angle of 25. Well, that's my second angle, right? You turn 25. From the original direction and running a total of 15 meters. Here's where your problem's going to be. Reading the word problem and finding out which variable goes where. Can I tell you, it's a big deal. And when you read these, and the more you practice reading word problems, the better you'll be. But choosing the right variables. That's the reason why, if you write everything out for me, I will know you chose the wrong variable, and I only have to take a couple points off. But if you give me 49 meters and 7.3 right, or those two answers, and they're wrong, I can't help you. Do y'all understand where I got the variables from? Yes, sir.
Question. Where did 0.0 come in
Where did he start? Or what is he doing? Is he running and stopping, or is he stopped and then he ran?
at?
Does he have an angle to start with?
No. So just
Sorry, he's just running straight down the field.
He has no angle. He's running straight down the field and then he turns 25 degrees. Okay? So then we do our X1 and our Y1. That would be this one and this one, right? We're gonna do the cosine of the angles, which we did. Did you get 35 and did you get 0?
Yeah.
Okay? The next thing we do is we're gonna do the x2 and the y2. Taking these two numbers, right? Cosine and sine, did you get 14 and 63? Are you good to that point? You might have a problem here, but once you have this, you can take that and run with it, right? Now you have the numbers, you're just plugging and chugging here. So this is easy. So let me ask you a question. Why are we square rooting this? Right. So if we're square rooting it, and we're putting 49 square plus 6.3 square, right? We're square rooting it, we should be able to get a number. You have to put it in exactly like it is here. Square root first, then the addition. People have a problem, sometimes they forget it's an addition instead of a multiplication. 49 meters. Once we get that from these numbers up here, then we're going to do our tangent, right? So what numbers are we using to get 7.3? I didn't put the numbers down, but what numbers are we using? Yep. And then that's where we get 7.3. I'm going to ask you to do question number 2. I'm not putting it on the board, but when you get done, call me and I'll come by and I'll look at your answer. If everybody gets it right, guess what we're going to do? We're going to go on. As long as you have this in your notebook, you've written down all the steps for at least 2 of the problems, you'll be able to handle the problem that you have on the test.
So are we gonna do another one right now?
We're doing number 2 now. Let's do number 2. And what I normally do, if I'm taking the test, I'm writing this down on a whiteboard so I can erase everything and just plug the new numbers in. And then I don't have to rewrite it again. Especially if Ms. Sloan wants a proof, you don't have to write it on paper, you can already have it on board. And this will be just like the test. The only thing you have to do is you take the problem that you have already, plug in your new variables, and boom, you got it all set up, ready to go. After yesterday's online problems, this was nice to see. Not difficult, but time consuming. Is your answer? I know mine's chicken scratch, and God bless you. But, you're doing good. You're here. I thought you were here already. That's what I got, but you're good.
Okay.
I was asking you if it's the answer, and you said yes, and I'm like, that's the difference that I have.
Oh, and then, what I got from that problem.
I want to let y'all know this problem took me 25 minutes to do. And it wasn't because it was difficult, it was just the writing part.
That's fine.
Yes.
Is I leaving like that or what? Do I run?
Okay, so then what did we do on the last problem?
So I ran these.
So look at your numbers, sig fig, look here. See? Yes. So I got on the board. Perfect.
Do I round differently than you? For this one, I've got 7.6.
I run it a little different. So I think my answer I got was. Let me see what my answer was because I didn't write it down. That's right, Hayden's got my calculator. Hayden, can I borrow my calculator for just a minute?
I got.
So I want to see what I rounded. Sir,
I had that right.
looks good. Let me check my rounding for a minute, Bailey, okay?
This one.
Yeah, 7.6, because it's 7.558438992. I'm so sorry. Thank you for asking. Yes, ma'am, I rounded wrong. Because it's 7.559. And I did not round up. Now you have to understand that was like late at night for me. If you are done with this, go ahead and take a picture of this for today's to put on that assignment, because that's what we were supposed to do first with these practice problems. If you've already done your notes from projectile, go ahead and post that on there. And then if you want to start working on the practice problems, you can if you want to try to get ahead. I'm going to wait on the guys. We're going to go over the notes a little bit. We're going to look at some of the formulas. And that's all we're going to do today. Okay? So use this time so you don't have any homework.
This one, you know how my computer was acting up, so when I post my photos real quick, real classroom.
Do you mind getting the iPad up that way so we don't break the rules? Thank you, baby.
Is it okay if we just get one?
Yeah, just open it up. No one's touched them.
This was from 9 to 5 and 1.
Yeah, I've got to change the thing, the way I've got it set up, I think.
So I'm going to submit the practice problems for,
I need to look.
I need the practice problems that we went over today, because that was what the video had, and along with your reading assignment from last night. That's all I need.
okay, so we don't have to worry about the practice problems for the reading for last one, with this heading here.
This one was yesterday, correct?
No, and this one was.
Oh, no,
practice
no, you're
problem
right.
today.
Yeah, this is what you're gonna submit for today. I'm sorry, I was kind of
So
confused there.
did these practice problems go on the 10 or 9?
The ones that we did today go under 10. The ones under 9 is the ones that we did online yesterday. Question? Sir? Where you at? Where you lost?
I wasn't lost. I thought you said ramp. You didn't ramp. You just took the numbers off. Yeah.
Yeah, well, I looked at the next number. And then I rounded
I
here.
had all these numbers. I asked, like, what do you do about those?
Yeah, so what you're gonna do is you're gonna look at the next, this one here, this one would determine that one, is what I was trying to say. Hayden, I'm sorry. And then that one would determine that one, and since it's not above 5, it stays that number.